Wonderful. Good afternoon, dear LinkedIn community Composites Lounge members. As we have indicated to you guys, we are together with Norbert, my business partner, preparing for AERO 2026, and we have an exclusive look inside Diamond Aircraft. And together with me is Gerhard Hüttinger. He is the quality manager of Diamond Aircraft, and he gives us an inside look into Diamond composite production. What will be expecting us, Gerhard? Just a very quick preview.
So we will see the full scope, starting from the first lamination process to the final aircraft. So it takes usually about 3 months to complete one complete airplane from the first part to the final aircraft. It's flown here, it's tested here, and if you pick the airplane, it's also handed over here.
And we will see a couple of composite parts, I guess.
All composite.
All of them. That's wonderful. Community, I will hand over basically this tour to Gerhard Hüttinger and Norbert, my business partner, because I will be the cameraman for this tour just after this break.
Welcome to the chat circle. Thanks for having us here at Diamond, Gerhard.
You're very welcome here at our Diamond manufacturing facility. So here we have separated the composite manufacturing process and the assembly manufacturing process, assisted with maintenance organization, flight training organization, and other supporting departments.
Yeah.
But here now we start in the manufacturing building for the composite process.
Okay, and here we see immediately the composites.
Yeah, but I want to point to this overview because we have two major processes. One is a wet layup process, and the other one is a vacuum-assisted infusion process.
Okay.
Yeah, so out of this process we produce, let's say, 95% of the structure. So it's manual layup. So it's one machine impregnating the dry fabric with the liquid resin and hardener. Then it's a manual layup process, which ends up with curing under vacuum. Yeah.
So it's no pre-breaks.
It's no pre-break. We call it just-in-time pre-break because we impregnate by machine, and so we have the wet laminate in our hands. Okay. So in this process has usually 3 stages. So we laminate both shells. Yeah. Then on the second day we start with bonding of all fasteners, ribs and let's say spars. Yeah? Cure it overnight, and on the third day we bond everything together. Yeah? Completely different is this process where we do a dry layup with some kind of membrane and flow channels, and we keep the vacuum while we let the resin flow through the part. Okay. So, but this process, it needs a lot of preparation, a lot of additional material, so it's quite a costly process. But you can produce a composite structure with almost 0 porosity. So those we use for special parts, like for the radar nose cone. If you order weather radar, also on the 62, yeah, you get a nose cone in this manufacturing process, and the wing spar caps, you will see in the production then, those are also produced in this process. Okay, then the curing is at that time just performed at 50 degrees. Yeah, so there is no hot curing in an autoclave. This allows us to demold the parts, cut the parts, and in the later stage we assemble the parts to an aircraft, and then it gets to the warm curing process. Yeah, the post-curing process is a process which is leading up to 125 degrees. The process takes over 24 hours in total. And then you have the final strength, also regarding heat resistance.
So then you are also having no problem to paint the Diamond aircraft in a black paint scheme.
We have to demonstrate different color codes. So the darkest that we have demonstrated is this anthracite. Yeah,
like
with
the
this
demonstrator now.
exactly. We have not demonstrated black.
Okay.
Yeah, so you would have some let's say outside temperature restrictions if you insist on a black aircraft. Okay, and here we see out of this vacuum assisted process a sample what is possible to produce. So this big part, including the stiffeners inside, was produced in one shot. Yeah,
Okay.
was a fuselage for the D-Jet project. Yeah, later then the floor and the front is bonded, but this is the one shot out of a vacuum assisted process.
So no halves, like in that case.
Exactly.
Okay.
Yeah. So here we are now in the manufacturing room. Yeah, so you will see the impregnation, the layup, the curing process, and in a separate room is then the cutting process.
And do you manufacture all airplanes then in here, or do you have different production lines for the different types?
We have several composite suppliers in the neighbor countries regarding components. The major components for a few types are produced here, and some we get from our facility in China.
But the major are here, but you don't have a dedicated DA62 production line or a DA20 production line. It's all mixed.
We do all at the same time, but of course there is a 62, a 42, a 40 and a DV20 production line.
Ah, okay. It's not. It's not interchanged in the same place. No.
It's mixed, you know, because each aircraft type is usually at the moment produced in a 5-day process. And on Monday we start with 62, on Tuesday with a 42.
Okay. So in that process then, okay, by the times. Good.
So here you see our different types of impregnation machines. So most of them are in-house built, in-house designed and in-house built.
Okay.
Those we use at each of our facilities, and they give really a reliable impregnation of the dry fabric.
Okay.
The fabrics that we use are mainly glass fiber and carbon fiber, where let's say, the larger the aircraft, the more is the carbon component.
Okay. Yeah. How much is in the DA62 the percentage of?
98% of carbon fiber.
Yeah. Okay.
Yeah.
So only things like nose cone and so on, then for special things.
Yeah.
Okay.
Here we use different types of fabrics. So glass fabric with strength like aluminium, carbon fabric in a strength like steel. And those are specially designed for manual lamination. So this carbon fiber has a strength like a steel, yeah. And as a special design feature, we use a carbon fiber with a small wire woven with the fire to make it lightning protected. So when the lightning occurs, this layer will distribute the energy. You reduce the local damage. Yeah. And so all our carbon aircraft are covered, the last layer, with this special fabric. Already said before, this is the end of the second stage. So all ribs and fasteners were already glued to one side. We glue with the same epoxy resin which we use for lamination, make it to a paste with a mix of cotton flocks and silicon bubbles. Okay. And with this bonding paste we can fill gaps from 1 to 10 millimeters without any issues with the same bonding paste. So you see some overlapping area between the left and the right shell, and each of these ribs is bonded on both sides. Yes. So this gives the strength to the structure. And at the end, a fuselage of a 62 will have in total around 150 kilograms. 150 kilograms only? Yeah. Okay. And then you have those few spars and a few ribs on the floor in there, right? Exactly. Okay. So and you see already the place where then the huge center wing is connected to the fuselage. Yes, of course. Okay. Yeah, and a further feature for lightning protection
Okay.
is that we have a complete aluminium tube skeleton through the whole structure.
Yes.
And in this skeleton we lead the necessary wiring.
Okay.
So if the lightning really succeeds to get through the structure, it runs down the aluminium skeleton and does not influence the necessary wiring.
Okay.
Because
so
we have an ECU controlled engine with a Garmin flight management system, so we like to have electricity.
Yes, and all the cables are protected by the tube essentially then, because the tube takes over the lightning
energy,
protection energy here.
So, carbon lamination is a certain challenge in regards to glass fiber lamination, because on glass fiber you see if there is air between the layers, and you can focus on getting the air out. On carbon lamination, you really have to do the good workmanship, and you have to see and feel if there is air between the layers.
And to push it really out.
That's why most of our composite employees are here 10 years, 20 years already.
And they feel where is the bubble.
Yeah, exactly. Big surface parts like wings, fuselage, we integrate a foam into the structure to get a sandwich part.
Yes.
Yeah, so we get some distance between the outer and ear layers, which make them more stiff at the same weight.
Yes, yes. The typical structure for hardening the structure.
Exactly,
yeah.
And those are the center wing spars. So with these 4 bolts, they connect both wings.
Yes.
Yeah. They take the load from the landing gear. Yeah.
So the landing gear is connected here.
Exactly. Yeah. And on top will be the fuselage at the end. And those parts are not produced only under vacuum, but in addition in a pressure tube. So we call them autoclave when it's not heated. Yeah. But we have another 3 bar outside pressure on the vacuum bag. And so we get a high condensed carbon fiber.
Okay. Through
structure.
The pressure of the vacuum then? Or?
Vacuum plus 3 bar additional pressure on the vacuum bag.
Okay.
Yeah. And as you can see here, specially designed, we have the landing gear mount glued to the spar.
Okay.
So if a customer does an ugly landing, damaging the structure, he's either cracking those ribs or the bonding. This can be replaced and the center wing stays alive.
And how can you make sure that there are no cracks then in the center wing? Because it's difficult to check the carbon fiber later.
The carbon fiber has a higher strength than the bonding.
So this will for sure correct the bonding before.
Yeah.
Okay.
And as we like to do a lot of composite gluing, you have to take considerations how to get the force from metal parts into the composite structure.
Yeah.
And our solution is that we integrate pre-pressed glass fiber plates into the structure. So the dark green areas here is a pre-pressed glass fiber.
Okay.
Those we integrate into the structure, and so we get a load transfer from the composite to the metal part.
Okay. And you would need then only to exchange this part, but this one stays intact.
Yeah.
Okay. But the wings can be always dismounted through those
exactly. You remove the stainless steel bolts and take the wing off. So here you see the integration of the center wing spars into the center wing structure.
Okay.
You see the gluing process live. So we always bond with over amount of bonding paste, put them into place with a certain fixture, and then we clean the over amount. So like it looks here will be the final.
So this is the fixture
line
that keeps everything exactly at the right place, and then it will be glued, and then after it's hardened you take away the fixture.
Yeah, exactly.
Okay. And this is then the center wing, which is connecting the wings to the fuselage.
Exactly. So there will be similar bolts like this connecting the fuselage.
Yeah.
This is here the place for the engine mount. Yeah, and on top here will be the fuselage. Yeah, and here you see prepared already the ready to be glued components of the center wing. So you see they are already prepared on the fixture. Yeah, the bonding area is rough, which we achieve with a peel ply fabric. and additional hand grinding. So this has to be perfect, rough and clean for the bonding process.
For the bonding.
Okay, so don't touch it now.
So this is our big CNC cutting machine,
Okay.
because you have to produce composite parts with oversize and then cut to the final edge. You
Okay.
cannot produce a perfect edge on composite.
Yes.
Yeah, so all big parts are cut on this machine. So the wing, center wing, fuselage. Yeah. So it's a 5X machine, taking the optimum tool for the cutting process. And all other smaller parts are cut by hand.
Okay. But this is then pretty much automized.
This is a CNC automated machine.
Okay. So he is only controlling what is happening there.
Yep, yep.
Wow, that's a lot of production know-how that is in there. But as I know, aviation is extremely much also paperwork and certifying everything, that every part is tracked and everything is to the maximum safety. How is that handled within Diamond?
Yeah. So we have a full traceability back to the raw material, back to the operators, back to the inspections.
Yeah.
We still work with paper because it's for us still the most comfortable solution. One day maybe it's electronical. But in this documentation we have the full traceability of each component installed on a composite part, which raw material was used. Yeah. The working steps and the inspection steps are confirmed.
Okay.
So this is the way how we track the production and inspection process.
And that's then always for one part
Exactly.
of the serial number of the appropriate airplane.
Correct. In the end, you get a big aircraft log with all documentation.
So that will be handed over to the owner also.
A selection of those.
Okay, but you have it on file for every
exactly.
all times.
Because we have to keep it for the lifetime of the airplane.
Yes.
Yeah. Here in the pre-assembly process, we take care that all parts fit together. So we do a pre-assembly of the complete aircraft.
Okay.
Yeah. Because each bonding, everything that you do on the aircraft needs to be heat treated.
Yes.
So, and then when everything sits on its place, we go to the heat treatment process. What I said before, 125 degrees, heating up, and then we get the final structural strength and heat resistance.
If you want to know where you put the luggage, then you see it here. There is the luggage compartment in the nose cone of the Diamond DA62. It's quite small area, but in the back is also some larger area later.
So after the 3 layers of painting, we start with electric conductive paint. Then comes the color coat, and at the end the top coat, the clear coat.
Why electric conductive paint?
When you fly through electric loaded air, you collect in this layer the electricity and you bring to the dischargers.
Okay. To the static dischargers, those little things that are at the back of the wing.
Yeah, exactly.
Okay.
Yeah. So here I can show you one of our safety features.
Okay.
Yeah. Those are these so-called crash elements. So our seats are not movable. Our seats always sit on the front edge of on a strong spar.
Yes.
And on the rear side, they are quite flexible mounted. Because if you certify nowadays an aircraft, you have to demonstrate that you could survive a standard aviation crash, which is 6 degrees against Earth. Yeah.
Okay.
Initial impact 23 G.
Oh, okay.
And you have to demonstrate that your structure can absorb 23 G. Yeah.
Wow.
And this we achieve with an, let's call it, almost indestructible seat, which is made of carbon and Kevlar fabric, and some shock absorbers. So those elements will absorb the load in case of a crash. So these are for the rear seats, and here will be for the front seats the same shock absorbers.
But that means that such a shock absorber needs to absorb something like 2.3 tons, 2,300 kilograms or something. Because if I'm almost 100 kilograms, no, not that much.
No, you absorb with the whole structure.
With the whole structure.
So,
but here, essentially, impact with 23 G gives you also 2.3 tons here onto those holding devices in that moment, right?
The 23G is for the whole structure.
Okay.
Yeah. So you demonstrate that with the whole, let's say, element, or that's the whole fuselage. The dummies sitting on the seat get a survivable load.
Yeah.
So it's acceptable that the rest of the structure absorb already a part of this 23G.
Okay,
So you don't have 23C
on the seat, on the person.
Okay, so this is the center wing to the blue fuselage that you saw there.
Okay.
It's already prepared with those crash elements. It's already prepared with the copper foil.
What for is that copper foil?
The copper foil is a protection against high radio frequency. Because there should be no impact on the aircraft if you fly over a radio station.
Yes. Okay. And that is often at the airports, of course, that you have such radio stations.
Yeah, but could be really a radio, so a music radio station as well.
Okay. Good, yeah.
And as long as we don't have a metal structure, we have to add on certain places some metal.
Okay. Also additional protection for the passengers inside and pilots.
Mainly for instruments. It's not, I mean, the humans would survive, but you have to protect the electronic devices. Okay, as I said before, these are our non-destructible, or that's almost non-destructible pilot seats. And,
so that's the seat bottom now here.
Exactly, we look from the bottom. So here you see our carbon Kevlar reinforced seat.
The yellow is the Kevlar in there.
Kevlar is exactly, This is the edge where it's sitting on the spar. Yeah, and here will be the flexible mount in the rear.
Okay.
And all of the structure we cover then with nice leather.
Oh yeah, that looks good already.
Yeah.
And here is the control stick then.
Exactly.
Good. Now here, that looks strange. That looks not more like a wing.
Yeah. Okay. Let's focus first on the wing fuel tanks.
So it goes into the wing.
These are aluminium tanks. Which are flexibly connected, that they can follow the movement of the wings.
Yes. Okay. If in case of bending of the wing.
And we prefer the solution of aluminium tanks for several reasons. One, it's easy to install and maintain. So if there is any issue, you defuel it, you take it out, you fix the issue, install it again.
Okay.
So for us, it's very much easier than a wet wing, for instance. And aluminium is still a lightweight material.
And wet wing would mean that there is not a separate tank inside, but the structure is
covered with sealant.
The sealant and the structure is already giving the tank. But in the big airliners, it's always wet wings, right?
Yeah, but there it's easier that you get somebody with a mask walking in and fix the issue.
Yeah, you don't walk in there.
on our airplanes, it would mean cutting a hole and fix the issue.
Okay, yes.
Our auxiliary fuel tanks.
Okay.
From the 62.
Yes.
So they are sitting behind the engine mounts.
Okay.
Give you another 50 liters of fuel.
Yes.
And those are produced in rotation melting process.
That means?
So you have 2-half mold. You fill in a defined amount of powder.
Yes.
You start rotating and heating.
So that everywhere in the end
it starts melting and everything is covered with the same thickness.
Because of the movement then that you control.
This is rotating in a certain movement to get the constant thickness. And by this you can integrate fuel lines and other elements into the tank.
Nice. So that means you have a mold which is then exactly having all those forms in there.
Yeah.
Interesting.
And it's the same process like sports kayak are produced.
Okay, so now we have here the part of the wing and tanks already installed, right?
Correct. Yeah. So it's quite easy. There are a few elements holding the tank inside. There are a lot of fuel ribs keeping it in place, but just 2 screws and you take the tank out and put it in.
So you can take it out from here?
Exactly.
Okay.
Yeah. Here you see already the copper bushings, where then the main boards, we call them main boards, connect the center wing with the wing.
Okay, and the same then for the small connectors here for all the control surfaces.
Exactly. We operate our controls with push rods.
You see there.
So only the rudder is operated with cable.
Konntest du das drehen jetzt?
No, you can push it and then you see
the push.
You can see the push.
And out there the aileron is
This is the
now
aileron,
moving.
and this is the here for the landing flap.
Aber die ist wahrscheinlich
We
kopiert, oder
we
wie?
just block it here for transport purposes, but this is
no.
the connection to the landing flap.
Perfect.
As all of our airplanes can also be used for training purposes, you can all of our airplanes steer from the right or the left.
Yes,
See.
both sides. Yeah.
Two wing spars.
Yeah.
As you have seen already on the center wing spar, we have two of them
Yeah.
for several reasons. One is an unlimited lifetime.
Unlimited lifetime.
Unlimited lifetime. So usually you have every few thousand flight hours a structural inspection, and
Yeah.
you extend by the next 3,000 hours. Second is we have demonstrated fail-safe design. So if one spar would fail, the other one can still guarantee a safe landing.
Okay.
And the third best reason is that we have a very protected place for the fuel. So it's really
in
protected
between.
by two spars. So in
Okay.
case of a crash, it's very unlikely that our aircraft burns.
So essentially that also means that in this case the lifetime of the airplane or the age of the airplane doesn't matter, because it's for sure from the structural point of view always a safe airplane.
We had to demonstrate this fatigue
Yeah.
demonstration for the major components.
Yes.
That's why we came to these inspection steps and the unlimited lifetime.
So you demonstrated that it's so durable that it's unlimited lifetime. You can
Exactly.
guarantee there on it. Yeah.
If I remember right, I think there were more than 10,000 load cases.
Wow. Wow, and here is already the engine now connected and installed. So
Exactly.
we are
There were some preparing assembly steps before.
uh-huh.
So the major marriage that we call is when we connect the fuselage with the center wing.
Yes.
Because from that moment on, they stay together for the rest of their life. Yeah? And when this is done, we can start with the engine installation. In this case, it's our Austria engine, diesel alias jet engine. And you can see already also some options that are available to the customer, like an oxygen bottle.
Yes.
Yeah?
important,
So you connect your cannula and you take the oxygen that you need.
Yes.
Because the engines are certified up to 5,500 meters,
Okay.
but the human will need
Need
some oxygen in
yeah.
between.
That's the
Here will be the
oxygen bubble.
space then what we see in the later assembly for the weather radar.
Yes.
Yeah? And you can also choose the option for the de-icing, what we see better than on the installed wings.
Yeah, all important safety feature, the de-icing, the oxygen, especially in commercial aviation and in passenger flights that we do.
Just out of curiosity, why is the blue here?
So we have a different color for cooling hoses, different color for fuel hoses, so that it's clear to everybody what medium is flowing through there.
Makes perfect sense.
So here is already almost finished, or?
Correct, yeah. So we had some assembly steps. We have a detailed inspection before we assemble the airplane. And then we assemble the airplane and we start with all system tests of hydraulic, landing gear system, avionics system, de-icing system, all features. So in this case, it will be a multi-purpose platform.
Yes.
So that's why there is the option of on-top exhaust available.
Why
So,
that?
to have no infrared signature for those on ground who don't like that you survey them.
To
okay.
be in disguise.
Exactly. And here you see our de-icing panels. These are titanium panels,
Yes.
which are very fine laser drilled.
So there
So
are
we-
holes in
The
here.
holes inside, exactly. You need good eyes to see the structure of the holes. So we have a fluid, a de-icing fluid tank on board, which we switch on the pumps and they start to cover the wing. They cover also the aileron and landing flap. So it's an ice avoiding system. And this allows you to fly a certain time depending on the mode that you switch on in icing conditions.
So you can safely fly over the Alps in icing conditions, and
It's
you have
certified for flight into non-icing FICI.
What strange thing is here in the front?
So this is the very popular Garmin weather radar.
Ah,
So it delivers you the real weather in front of you, You can tilt it left, right, up, down. Yeah,
Like a radar dish here.
exactly.
So this is the radar dish.
This is the radar, exactly.
Okay.
And it gives you on the Garmin G1000 the real weather information in regard to your flight route. So you can really then divert 5 degrees, 10 degrees to the left, for instance, to avoid ugly weather in front of you.
Okay, and is it only this small item, or is there a big instrument also connected with it?
This is the, let's say, for the weather radar, it's this component, and the rest of the Garmin system will be installed here. So all these flight data computers, air data computers, and everything will be installed in the big Garmin box.
Okay, so you have one more box in here if you have the radar additionally.
No, this is the standard box.
Uh-huh.
And the option weather radar just adds the device in front.
Ah, okay.
Yeah, because you get all, let's say, avionic equipment already here and have just, let's say, the screens installed inside.
Here's already the cockpit line.
Exactly.
It looks like.
And as we said already, all the avionic units are already in the Garmin box there. That's why on the cockpit we can focus on the screens, on the buttons and switches, and on the fuselage.
So here is only the human interface to the pilot.
Exactly.
But still lots of cabling and lots of different connectors. How much cable is in such an airplane in the end?
It's hard to estimate, I would say several hundred meters.
Yeah, kilometers I thought as well, yeah. So we have here the DA40 already almost finished, right?
Correct, yeah. So we have the last inspection and the last tests on the assembly airplane before we go out for the first ground run. So we monitor if the laptops, if the ECUs are happy, in this case one ECU for the single engine. And then we do all tests on the running engine. And if everything is satisfying, we release the airplane for the production test flights, which takes us usually about 3 hours, including a landing in Graz, where we have to demonstrate that the autopilot can fly the approach.
Okay.
It cannot land, but it has to be able to fly the approach.
Yeah.
And then after those 3 hours, we have a last finishing department where we prepare for the handover to the customer. So it gets its decals, its registration, and the design finally. And yeah, then any kind of handover to the customer, either here. Some of them get also their differences training here on their new airplane. Or we bring the airplane to the dealer, and the dealer hands over the airplane to the customer.
You do the ferry flight and then it's taken over locally.
For long ferry flights, we can install a ferry tank instead of the rear seats, so we can fly legs up to 12 hours.
Okay.
With the ferry tank.
And then you install the rear seats locally
on the final destination, we replace the ferry tank with the original seats. Yeah.
Okay, interesting.
How do we connect you with stories within the composites and sustainable materials industry? We are on the ground to find the facts. We examine big, innovative ideas. We let diverse perspectives on technology and sustainability emerge and ignite conversations that matter most to bring you the composites and sustainable materials world. Stay informed, stay connected, stay inspired. From our online studios in Germany, covering events and corporates from France, Italy, UK, Central Europe, and many more European regions. Join us for creating sustainable value.
With Composites 360 on tour, Composites Lounge engineering talks, and Composites Lounge end user panels hosted by Ilkay Özkisaoglu. Weekly on LinkedIn, YouTube, and your preferred podcasts.